Okay, I want to use a double integral to find the volume described by the segment of the cylinder x squared plus y squared equals 1, bounded above by the plane z equals 12 plus x plus y, and below by z equals 0. Sketch a region prior to integrating. Okay, so let's see. I want to start off with, see, this is x, y, z. Now think about this for a second. X squared plus y squared equals 1. If I just put this on an xy plane, that's the unit circle. So what I have here is this cylinder consisting of the unit circle, and it's just elevated up. So that's that cylinder that I'm dealing with. It's bounded below by z equals 0. Z equals 0 is the xy plane. So it's bounded below right here, and above by this plane 12 plus x plus y. Well, and when x and y is 0, this is going to be 12. So there's some plane up here that's going to cut this thing. And even though the cylinder will continue on, I'm just looking at where the plane cuts the cylinder, cuts through the cylinder between this point and the xy plane. So I'm looking for the volume that will be represented in here. That's really what I'm talking about. Okay, so now that I know the region I need to work with, I need to think about, I'm going to actually do this. So what I'm going to be working with here, I think, is probably the easiest way is think of this and think of this as a type 1 region. So I need a function for this piece and I need a function for that piece. Well, just take this. See, x squared plus y squared equals 1 implies that y equals plus and minus the square root of 1 minus x squared. Well, here's the plus and here's the minus. So what I'm going to do is go ahead and set up this integral now, and this is going to be the double integral. I'm going to start off going from negative square root of 1 minus x squared to the positive square root of 1 minus x squared. And this plane up here is the surface that I'm integrating underneath. So this is just going to be 12 plus x plus y. Now this describes what's happening to y. So this would be dy. And notice that x will go from negative 1 to 1. So this is the integral that I need to work with. So like usual, I'm going to start off with just this piece. Oops, I kind of forgot my dx, didn't I? There we go, dx. Now I'm going to start off with just this piece. Treat it like a separate problem. I have the integral from negative square root 1 minus x squared to the square root of 1 minus x squared. I'm sorry, that looked really ugly. Of, whoops, 12 plus x plus y dy. So that's going to give me 12y plus xy plus y squared over 2, evaluated from negative square root of 1 minus x squared to the square root of 1 minus x squared, which gives me 12 times the square root of 1 minus x squared plus x times 1 minus x squared, whoops, square root of, there we go, plus 1 minus x squared over 2, because it's squared, minus a negative, because it's negative here, 12 times the square root of 1 minus x squared, minus, I definitely ran out of room here, x times the square root of 1 minus x squared, plus, this is squared, so that negative gets squared. It's just going to be 1 minus x squared over 2. Now, if I drop this paren, I need to go through and change all these signs. That becomes a negative, so I can drop the parens. And let's combine these. And I'm going to have 24 times the square root of 1 minus x squared. And then this is a plus. So this is going to be plus 2x times the square root of 1 minus x squared. And these just cancel out. So I've got this nice little integral that I can work with now. So what do I have? I'm going to have the integral from -1 to 1 of 24 times the square root of 1 minus x squared. I can see, I'm going to break this up because the techniques I'm going to need for this one versus this one is going to be different. So I'm going to do this dx plus the integral -1 to 1 of 2x times the square root of 1 minus x squared dx. Okay, now the reason I broke this up. How do I integrate this? Well, I need a trig substitution here. I'm going to let x equal sine x. Then dx equals cosine x. I'm sorry, it should be theta, sine theta. So dx equals cosine theta d theta. So now what I have is 24 times the integral of the square root of 1 minus sine squared theta times cosine theta d theta. Well, this is 1 minus sine squared is cosine squared. Square root of cosine squared is cosine. So this is actually equal to 24 times the integral of cosine squared theta d theta, which I can work with as 24 times the integral of cosine of, not cosine, it's 1 plus cosine 2 theta over 2 d theta. Well, I'm going to cancel that out and go with the 12 right there. So this is going to give me 12 times theta plus sine 2 theta over 2, which is going to be 12 times theta plus, this is the same as 2 times sine theta cosine theta over 2, so the 2's a cancel. So this just be sine theta cosine theta. Now up here, where was it that I did that trig? Here. I said x is equal to sine theta, right? Well, if I draw my triangle, here's theta. Sine theta equals x. That means this is x over 1, which means this is the square root of 1 minus x squared. And I'm going to write this over here really quickly. We said sine equals, or x equals sine theta, right? So that means that what I end up as a solution for this piece is 12 times, I need to get back to x's now, 12 times theta. Well, theta is going to be arc sine of x plus sine theta, which is x over 1, times cosine theta, which is square root of 1 minus x squared. So now I'm back to x's, and now I can go back and evaluate this from -1 to 1. Clean this up just a teeny bit. Okay, so that's what we're working with. So let's go ahead and solve this piece. This is going to be 12 times, see, this is arc sine, my bad. Arc sine of 1, that is going to be pi over 2 plus 1 times 1 minus 1 is 0, so that's just pi over 2 plus 0, minus arc sine of -1, that is going to be a negative pi over 2, plus at -1, this is -1 times 0. So this is just going to be 12 times pi over 2 plus pi over 2, that's going to be pi. So this component is actually going to give me 12 pi. Now, I'm nowhere near done. Well, actually about halfway, because what I did was just this piece. I still need to worry about this piece. So let's go back and finish this. I need to add to it the integral from -1 to 1 of, I forgot what that was, 2x. 2x times the square root of 1 minus x squared dx. Well, see, this is much easier than the other one because I'm just going to let u equal 1 minus x squared. Then du equals a negative 2x dx. So negative du equals 2x dx, which is exactly what I have right here. So this is going to be the integral, the negative of the integral u to the 1/2 du, which is going to be a negative u to the 3/2 divided by 3/2, which is multiplied by 2/3, which is going to give me negative 2/3 times 1 minus x squared to the 3/2 evaluated from -1 to 1, which is 0. So my solution really is simply 12 pi. And that, I should comment on, that's the volume. That's the volume of this cylinder that resides between the xy plane and the plane 12 plus x plus y in between there, with the cylinder defined as x squared plus y squared equals 1. Kind of cool, huh?